So today we're going to talk about applying graphs to economics. As you may know, there are a lot of graphs in economics, and graphs can often be frightening to use. A lot of people don't know how to read graphs, and so they're scared of economics because they don't think they'll understand it. However, if you get a better idea of how graphs work, then you can get a better idea of how economics works. Why do we use graphs? As the popular saying goes, a picture is worth 1,000 words, and this is very true in economics. It's easy to present economic models in the simplest way using a graph. So instead of using a big paragraph, for example, with a bunch of words and numbers that can become really confused, we can present a picture using a graph, and it's a lot easier to connect different variables. So here we have some graph basics, and you can see here that your graph is divided into 4 quadrants. 1, 2, 3, 4. And each of these quadrants is divided by the x-axis, which goes horizontally, and the y-axis, which goes vertically. And each of these points on the graph that you see here line up with different points on the axes. So for example, if we look at point C, which is -3, -5, that is referring to the point on the x-axis, which goes first, and the y-axis. So we see here point -3 on the x-axis and -5 on the y-axis creates coordinate -3, -5. In economics, we're usually talking about things such as money, the price of different items, or how many items you're selling. So these are usually positive values. And because of this, we usually only use the first upper right quadrant, which is this L-shaped quadrant right here. So first we're going to talk about how to find the slope of a line. Finding the slope of a line will really help you understand how the graph works. So the slope shows the relationship between 2 variables, and you can find the slope by finding the change in the y-axis divided by the change in the x-axis. And this can also be remembered by saying rise over run, so how much the graph rises over how much the graph runs. So in this example, we have point 43 and point -2, -1. So we're going to find the slope of this line. So if we take these 2 points, we have point 43 and point -2, -1. So as we said, the formula is the change in y over the change in x. So the change in y is 3 minus -1. That cancels out, so we have 3 plus 1. The change in x is 4 to -2, and that also cancels out, so it would be 4 plus 2. So we add those together horizontally, and we get 4 over 6. As you know from math classes, we usually cancel this down, so it becomes 2/3. So our slope is 2/3. So this means that when y increases by 2, x increases by 3. So looking at this graph again, we can see that if we take the point -2, -1, and we increase by rising 1, 2, and we increase by running 1, 2, 3, we remain on this line. So there's a few different relationships that you'll study using graphs. And the first relationship we're going to talk about is a direct relationship versus an indirect relationship. A direct relationship is a positive association between 2 variables. So when one increases, the other also increases. So for example, in the problem that we just looked at, that is a positive association because as x increased, y also increased, and vice versa. An inverse relationship, on the other hand, is a negative association between 2 variables. So when one increases, the other decreases. So we can see in these 2 graphs, this is a direct relationship. So as x increases, y is increasing. X increases, y increases. On the other hand, in an inverse relationship, it's the opposite. See how this one goes up, this one slants down. So we see as y decreases, x increases. And vice versa, if we go the other way, y is increasing and x is decreasing. Another relationship is the independent relationship. And this is a zero association between two variables, and this is shown by a flat line. So we can see in this graph that we're looking at the annual income and toothpaste expenditure. And so we have a flat line here, which means that these variables don't affect each other. So someone who makes $100,000 in a year versus someone who makes, let's say, $30,000 a year, doesn't change anything about this graph. They pay roughly the same amount for their toothpaste. The final one that we're going to look at is a three-variable relationship. And this is shown by using a multi-curve graph. So if you look here, we see that we have two different lines. This one shows the annual income for $60,000, and this shows the annual income for $30,000. So we look at these two axes, and we see that this one is the quantity of compact discs purchased, and this is the price per contact disc. So if we see here, we can see that if you have an income of $60,000, then you pay more for your compact discs, and you buy more of them. However, if you only make $30,000 a year, you buy less CDs and you pay less for them. So there's some important terminology that goes along with this three-variable graph. And these terms are movements along and shifts in the curves, and they're not the same. A change in one of the variables shown on the coordinate axes causes movement along the curve. On the other hand, a change in one of the variables that is not shown on the coordinate axes causes a shift in the curve. So, looking at the previous example, if we wanted to find the movement along the curve, we would look at two different variables. So, right here, if we looked at this coordinate and this coordinate, we would see that it is a movement down the curve. However, if we looked at two different variables, such as this point and this point, we would see that it is a shift left because it's moving left down the graph. So we're going to look at some real-world examples so you can get the idea of how these concepts apply to economics. So let's say you own your own pizza shop and you want to determine the relationship between the price of pizza and the number of pizzas that you sell. Obviously, you want to make more money, you want to sell more pizzas. So after selling pizzas at different prices, you report the following information. When the cost of pizza is $20, you sell 0 pizzas. When the cost of pizza is $15, you sell 20 pizzas. And when the cost of pizza is $10, you sell 40 pizzas. So we're going to graph this line. All right. So we have our graph here, and first what we're going to do is name our axes. So you can choose whichever one you want, but I'm going to say that my x-axis is the number of pizzas. And I'm going to say that my y-axis is the price. And I'm going to go by fives. So 5, 10, 15, 20, 25, 30, 35, 40. And I'll do the same thing on the y-axis. 5, 10, 15, 20, 25, 30, 35. All right. So the information that we reported can be turned into different coordinates on your graph. So when we sold pizzas at $20, we made 0 pizzas. So since the x-axis is the number of pizzas, we're going to make that our x-coordinate. So we sold 0 pizzas, and our y value will be 20 because that's the price. We sold 20 pizzas when we sold it for $15 per pizza, and we sold 40 pizzas when we sold them for $10. So now all we have to do is plot these points. So first here we have 0 pizzas sold at $20. So we find $20 on our graph and find 0 on the x-axis, and we plot that point. Next we have 20, 15. So we find 20 on our x-axis right here and 15 on our y-axis, and we plot that point. Then we plot our final point, 40, 10. We find 40 on our x-axis and 10 on our y-axis, and that brings us to right there. So as you can see, these points go in a straight line. So all we have to do is connect the dots. And there we have our graph. So what does this mean? What can we use this information for? If we wanted to, we could find the slope. So slope is change in y over the change in x. And let's say you can use any of these points. So let's say we're going to use 0, 20, and 20, 15. So 20 minus 15 is 5. And 0 minus 20 is negative 20. And we cancel that down to be negative 1/4. So our slope is negative 1/4, which means that as y goes down 1, the x value increases by 4. So down 1, across 1, 2, 3, 4. So we can use this to find the later values that we haven't been given. So if we see here, we go down 1 and over 4. 1, 2, 3, 4. 35, 40, 45, 50, 55, 60. So this coordinate would be at 5, or at 65. So we can connect that dot as well. So let's say you want to figure out what price of pizza makes you the most money. So to figure this out, we could choose this point, for example, and say, well, $15 a pizza, we sell 20 pizzas. So 15 times 20 is 300. So you're making $300 if you have the price set at $15 and you sell 20 pizzas. However, over here, if you sell 40 pizzas at $10, you're making $400. That's 10 times 40. And on this coordinate that we found ourselves, we have 65. If we multiply 60 times 5, then we're making $300. So if you're trying to figure out what price of pizza would be the best, which one is it going to be? It's going to be the one that makes more money. So you're going to want to sell the pizza at $10, which will sell you 40 pizzas. So the last problem we're going to look at is this one. So the graph on the next page represents a 3-variable relationship. As the annual income of consumers falls from $50,000 to $30,000, the result is an upward movement along each curve, a downward movement along each curve, or a leftward shift in curve A to curve B, or a rightward shift in curve A to curve B. So if we were looking here, we're talking about the income falling from $50,000 to $30,000. So we'll look at this example and we find our annual income, $50,000 to $30,000. So if we're looking at coordinates that are on the same line, then that'll be a movement in the curve. But if we're looking at different lines, then it'll be a shift. So we're looking at different lines, which means that it's a shift. Is it moving left or is it moving right? It's moving left, therefore it's a shift left in the curve. So that is how to use graphs in economics. And hopefully you'll have a pretty basic idea of how to use graphs and you won't find economics as scary, and you'll learn to love economics. Thank you.